Question 13 reads, in order for a photon to eject photoelectrons from the surface in the photoelectric effect, the photons, so we'll go ahead and read A, B, C, and D and go through these. So A reads, the energy must be below the work function of the surface. Well, we know that if the equation reads kinetic energy max is equal to energy minus the work function, then we know that we must have a certain energy that can overcome the work function in order to result in the kinetic energy or the movement or the ejection of a photoelectron from the surface. So we know that A cannot be correct, and if we were going to correct it, we would say the energy must be above the work function. B reads, the wavelength must be below a certain maximum value. This answer is actually correct. So what you might commonly see in lecture is that the frequency must be above a certain maximum value. And that's because for frequency is directly proportional to energy. So once we have a certain frequency of a wavelength, or once we have the certain frequency of a photon, then we have a certain energy, and once we reach the desired energy to overcome the work function, then it will result in the ejection of a photoelectron. So because we know frequency and wavelength are inversely proportional to each other, we know that the wavelength must be below a certain maximum value, because as we decrease the wavelength, we are going to increase the energy. So we'll go ahead and continue, even though we know that B is the correct answer. C says the frequency must be below a certain minimum value. So like I said before, frequency is directly proportional to energy. So we need to have frequency at a certain maximum value. It must be above a certain maximum value in order to have the necessary energy to overcome the work function. And D reads, speed must be greater than a certain minimum value. So speed actually has nothing to do with it. So that's why the answer for number 13 is B.